This is the last question on this paper, and it is about changing state of substance as well as raising its temperature. So it is about specific heat capacity and latent heat. The question says a student investigated how the temperature of a lump of ice varied as the ice was heated. So in this case, I can make use of this statement again, and I can say you will supply thermal energy and you will record temperature. Now, throughout this investigation, you will not change the mass of the object, which is ice. It says the student recorded the temperature until the ice melted and then the water produced boiled. Ice melted is my state change. Boiled is again my state change. So the both of them involve state changes. It says figure 17 shows the student's results. The power output of the heater was constant. This is again an important statement. This means energy supplied to ice in 1 second was fixed. This means was constant throughout. Now the results of this investigation are given to us in the form of graphs. This graph is important. Let's quickly annotate on this graph. So they started with ice, so I can say this is ice, this is water, and this is steam. Remind yourself, state change always happens at fixed temperatures. This is state change, and this is also state change. One more thing that we have to remind ourselves about is in this section the temperature is increasing, so the gradient of lines in this case will be representing the change in temperature that will take place in 1 second. Now the question says the specific heat capacity of ice is less than the specific heat capacity of water. Explain how figure 17 shows this. So they've given us a statement telling us that the specific heat capacity of ice is less than the specific heat capacity of water, and we have to explain this statement using results from this figure. Now I can't answer this question until and unless I know what specific heat capacity means. So let's remind ourselves about this. So I'm going to say it is energy required to raise temperature by 1 degree Celsius of 1 kg object. Keeping this in mind, and alongside with this diagram, I can produce my answer to this question. So I'll say here, ice has steeper gradient. Now steeper gradient means what? I just made it clear to you people here that gradient in this case is representing the change in temperature that will take place in 1 second. So if it has a steeper gradient, then the change in temperature in 1 second will be bigger, and that indicates that it would use less amount of energy to raise its temperatures. We can say less energy is required to raise its temperature by 1 degree Celsius. The next part says the specific latent heat of fusion of ice is less than the specific latent heat of vaporization of water. Explain how figure 17 shows this again. So again, it's a similar question to the previous one, but this time it is about fusion and vaporization. And whenever you use word latent heat, this is for state change. So in this case, I'll say it is energy required to change state of 1 kg object. So we have to use figure 17 again. So what we'll have to look at is, this time we'll focus on the horizontal sections. So I can see here, when it was ice, it changed its states in a shorter amount of time. Compared to water, it took very long for it to change its state. So I'll say ice took shorter time to change state. This indicates less energy was required. The next part of the question says the second student did the same investigation and recorded the temperature until the water produced boiled. In the second student's investigation, more thermal energy was transferred to the surroundings. More thermal energy was transferred to the surroundings. So what will happen? I can say as a result of this, time will go up. It says describe two ways the results of the experiment in figure 17 would have been different. So again, if I look at this figure alongside while I'm writing the answer here, this will take place in longer duration of time. So the line will become less steeper. So we can say the lines will become less steeper. In other words, I can say gradient will go down for all sections. And this is because it will take longer for temperature to increase. For the second mark, I can talk about the horizontal sections. So what will happen to the horizontal sections? They will also increase. The lines will become longer. Why will they become longer? Because more energy will go into the surrounding. So it will take longer for the state change to take place. We can say the horizontal lines will become longer. This is because more time will be required for state change. The last part of this question says when the water was boiling, 0.03 kilograms of water turned into steam. So this is the value of mass. The energy transferred to the water was 69 kilojoules. Now this is my energy, but I can't use energy in kilojoules. I'll have to convert the unit. It becomes 69 times by 1000, which is 69,000 joules. Calculate the specific latent heat of vaporization of water. So the specific latent heat has a formula which is Q equals M times L. Let's put down L equals question. Now I wrote E for energy here, but when you use this expression, Q is same as E. Okay, so I can just replace them with their values and solve, and I'll end up with the answer. So instead of Q, I can write down 69,000. Mass is 0.030 times by L. To solve this equation, I'll divide both sides by 0.03. This side, this will cancel out. I'll be left with L. If you put this in your calculator, you'll end up with a value of 2.3 times 10 to the power of 6. Now it does ask you for the unit. So the unit for Q that we have used is joules, and the unit for mass is kilograms. So it will be joules per kg. So I'll write down 2.3 times 10 to the power of 6, and unit is joules per kilogram.